Alrighty, young humans. So there's been a change of plans. I am not going to be at school today. Um, Hopefully they go fix my board, and then Wednesday I'll get to come in and do some actual teaching. Okay, but let's just practice the stuff that we did yesterday. Okay, so if you look at the back of the room, just find where your class is, and your notes from yesterday should be back there. Alrighty. So you guys can take those back. If you didn't turn them in, make sure you turn them in so I can grade them for you. Alrighty. So first we're just finding a dot product. Doesn't matter what form they give us. Remember, this IJ form is the same thing as this component form. Don't matter. Okay. So we're just going to do the x's times the x's. So that's a -1. Okay. So we got a -1. So u dot v, that's an arrow, is equal to -1 times -6 plus 5 times -2. All right, so that's going to give us +6 plus -10, which equals -4. Okay, so there's our dot product. For these first couple, that's all you're doing. If you notice on like number 3 and 4, it's just a different notation. So they drew it, but really you just read these. This is the component form of it anyway, right? So they're telling you the endpoint, but they're both starting at the origin. So the vector here is 8, 4, right? Since it started here at the origin. All right. So again, you're just doing the dot product, x times x, y times y. Okay, so those first 4 are the same. Now this next one is what's really, really important, because this is usually what matters, what we're looking for. We're looking to see if the vectors are parallel. Okay, so let's just talk about parallel. If they are parallel, then cosine theta equals 1. Okay, right? Because think about it. When is the angle between the vectors going to equal, or cosine of the angle between the vectors going to equal 1? Well, that would be at 0 degrees or at 180 degrees, right? 1 is cosine 1, 0 degrees. That means they're going the same direction, okay? If you get also cosine theta equals -1, that means that they're also technically parallel. They're just going in opposite directions, okay? So both of this is what we're looking for if we're looking for parallel. The one that really matters, though, is orthogonal. Okay, and I told you guys that's just our new word for perpendicular. So this word right here really just means perpendicular. Okay, but it can also be used in three-dimensional space. And this is whenever cosine theta equals 0. Okay, and this one's easier to find because basically it's just, if your dot product is 0, then the whole thing is going to be 0, because our equation from yesterday was cosine theta, so cosine of the angle between the vectors, is the dot product of the vectors over the magnitude of the vectors. Right. Well, no matter what, if the dot product is 0, then this whole thing becomes 0. So as soon as we know that this dot product is 0, then we know that the vectors are perpendicular to each other or orthogonal. Okay. And if we don't get that, then we're going to have to actually go ahead and find the magnitude so that we can see if they're parallel for some reason. So let's do number 5. Okay. I have a feeling that these are going to be orthogonal. So let's see. This is going to be the dot product. That's what we want to start with. U times V is going to equal, what is -4 times +4 times -9? That's going to be -36, maybe, yes, no, maybe so, yeah. Plus -9 times 4, that's also -36. Oh my goodness, I played myself. That is not 0. That is -72. All right, so if that's negative 72, we're going to have to find our magnitudes of u and v. So let's find our magnitudes. Magnitude of u, change color right there. Magnitude of u, that's just going to be our Pythagorean theorem situation. So the magnitude, oh god, I did not change colors. Let's try that one more time. Okay. The magnitude of u is the square root of 4 squared plus 9 squared. Again, remember, I don't trust y'all. Just don't put the negative sign. Just go ahead and use the positive sign. Okay, so 4 squared plus 9 squared. That is 81 plus 16. That is the square root of 97. 81 plus 16. Yeah. Okay, magnitude of v, that is going to be the square root of, and again, don't trust y'all to just don't put in the negative sign, 9 squared plus 4 squared, and this one's going to be the same thing, so square root of 97. Okay, so now what we're looking for is, we're going to set up, this formula here. So cosine theta equals negative 72, that dot product, over the product of these magnitudes. So square root of 97 times square root of 97. And we'll put that in the calculator real quick, see what we get. So negative 72 over square root of 97 times square root of 97. Let's see what we get here. So negative 72 over square root 72 times square root of 72. Wait, did I put those in right? No, 97. My bad, y'all. Tripping. 97. 97. Put this in. We get something that is not negative 1, positive 1. So these are not parallel either. So we're going to say neither. So these are neither. Wow, that's bad. Okay, neither. And, just for funsies, if you wanted to find the actual angle, so these are neither because this does not come out to negative 1, positive 1. And it didn't come out to 0 either, so that's not perpendicular. If you wanted to find what the actual angle was, remember, all we got to do is cosine inverse. Whoa, did I mean to press that button? Let's see here. Cosine, so go to trig, cosine inverse, and all you're going to do is cosine inverse that angle. So I can just copy it in here. If I do cosine inverse, it'll tell me what that angle is. So we have a big angle, 137.9 degrees is the angle between these two vectors. Okay, so this question doesn't ask for that. Okay, but if you wanted the angle between the vectors, this is the angle between the vectors. So if you want the angle, you just do cosine inverse of whatever this was, right? Whatever your dot product over the magnitudes product is. So again, try this one. If you get that the dot product is 0, you can stop because they're perpendicular or orthogonal. You could write either word. I prefer orthogonal, actually. And if you don't get that, you're going to have to do all this work and see if you get a positive or negative 1. And if you get a positive or negative 1 for all this situation, then they're going to be parallel. If you don't get either of that, then they're neither. Okay. So on the back, that's what you're going to do. So on the back, you're doing that last step I was putting. Okay, you're doing the cosine inverse. Okay, so to find this angle, you've got to do cosine inverse of the dot product, u times v, over the magnitude of u times the magnitude of v. Okay, that this is what you're doing if you want to find the angle, okay? So let's just kind of, I'm just going to help you guys write down what U and V are. U is -2, 2, and V would be, and you could use other letters if you want to, if you're tired of using the same 2 letters. There's your 2 vectors. So find your dot product, find your magnitudes, cosine inverse of those. Okay, these are obviously not going to be orthogonal, so you don't have to worry about that part. And that's about it, I believe. Let's see what else we got here. Yep, these last ones are just finding the angles. Okay. Oh, snap. Look at this one. Here's a trickety trick right here. So let's just talk about number 10 real quick. Remember, this one just says -8j, right? The other one says -9 and -9i, -2j. So there's your x, there's your y. But this one just says -8j. So we've got to obviously, hopefully, just think about it a little bit. What would that imply that our x component is? Well, that means that we've really just got 0i minus 8j. Okay, so that's what you're going to use. 0 times -9, -8 times -2 to find that dot product. Okay, so again, if you want to do it all in one step, in the calculator, you can just put in cosine inverse. That looks like a big S. Cosine inverse. Orange was probably not the best color to use there. Cosine inverse. Now that looks like a plus sign. Cosine inverse of the dot product over the magnitudes. Okay, but I would find this number by itself and then do cosine inverse of it, because it's going to get too messy. You might hit too many buttons and mess it up. All right, well, hopefully I will see you guys Wednesday, and hopefully my board will be fixed by then. Have a good one. Be nice to the sub.